Hello everyone, we are going to discuss about MOSFET structure. So transistor, when you are taking transistor, that is classified into two types. One is BJT, other one is FET. BJT means bipolar junction transistor, FET means field effect transistor. So FET again classified into JFET and MOSFET. JFET means junction field effect transistor. MOSFET is nothing but metal oxide semiconductor field effect transistor. Now we are going to see about MOSFET structure. What is a MOSFET and MOSFET structure? So inside the MOSFET there are some terminals we are having. Those terminals are source, gate, drain and substrate as a base material. These are all the terminals we are having inside the MOSFET. Actually first you should know why we are calling this FET as MOSFET, metal oxide semiconductor FET. The reason is here we are the top layer is metal and the below that metal layer we are having insulator as the second layer. Below that we are having substrate that will be acts as a base material. So we are having metal layer, oxide layer and then substrate layer. So because of this reason we are calling this as metal oxide semiconductor FET. This is the reason why we are calling this FET as MOSFET. So next this MOSFET, this will be acts as a amplifying device. Otherwise we can make use of this as a switching device, and this is having very high switching speed, and this is also called as voltage control device. We will discuss in further PPTs what is why we are calling this as voltage control device. So MOSFET classification, when you are taking MOSFET classification, there are enhancement mode, depletion mode. In each we are having N-type MOSFET, P-type MOSFET. For P-type MOSFET, we should take N-type semiconductor as the base material. When you are taking N-MOSFET, the base material is P-type substrate. So before going for actual MOSFET structure, we are going to see what are the basic structure we are having before that MOSFET structure. Now why the MOSFET structure we are having, that means what is the basic structure for actual MOSFET structure. See, this is what very simple diagram. Here we are having three different layers. First one is conductive plate, second one is dielectric, that is insulating material. The third one is P-type silicon. So what will happen when you are connecting these this structure into one power supply? What will happen? That we will see next. So first of all we are having one metal plate, no? The top layer, that is called metal layer. So here you can see that is conductive plate, and next insulating material. The last layer is substrate, which is a doped one, that is semiconductor, P-type semiconductor. So now I am going to connect one supply, that is V1 here. That positive is connected to top layer and negative is connected to P-type substrate. What will happen? Because of the positive, the top layer will be occupied by positive ions. At the top bottom we have connected negative side of V1, no? So what will happen here, that substrate is P-type. So what will happen, the negative will attract holes. In P-type majority carriers are holes, so all the holes will be attracted towards the negative of V1. What will happen, that will leave negative ions at the top side. So there will be a formation of positive and negative ions near the dielectric region, that is insulating region. So what is this structure called? This is nothing but one capacitor. In the capacitor there will be two plates, in between we are having one dielectric. This is similar to capacitor structure. So there will be a positive and negative ion formation, that is in between we are having one insulating layer. So electrons will be formed at the P-type substrate. So now what we are doing is we are going to connect one more supply to that P-type substrate. So we are having at the sides of p-type substrate, we have connected two metal contacts, and through using that we are connecting one supply voltage V2. So negative is connected to negative of V2 is connected to left side, and positive of V2 is connected to right side. What will happen when you are connecting V2? Actually, there will be electron flow from left to right. Negative side to positive side. Those electrons will be flow through the channel, negative channel, which is already formed because of V1 voltage. So there will be a current flow. So this current flow depends on V1 voltage. If you are increasing V1, what will happen? The current flow inside the p-type substrate will be increased. If you are decreasing V1, the current flow inside the p-type substrate will be decreased. Why so? This is because of that capacitive formation. So the current flow is controlled by the supply voltage, the voltage V1. So this is called voltage control device. Current flow here is controlled by the voltage V1. So this is called voltage control device, and you can increase the negative ions by increasing the capacitance. If the thickness of dielectric region, if that is decreased, there will be a more capacitance. If there is a more capacitance, there will be a more number of ions formation. So if there will be a more number of ions formation, means what will happen? Automatically the current flow will be increased. So here the current flow inside the material is because of the supply voltage V1. So this is called voltage control device, and we are actually this basic structure is converted like this, converted into actual MOSFET structure. So here the previous at the two sides of p-type substrate, we are having two metal contacts now. Those two contacts are replaced by two N plus regions, two heavily doped N plus regions. Why so? Why there is a conversion means, if we are connecting two metals directly to the substrate, what will happen? The ohmic contact will be reduced. So in order to get good ohmic contact, we are connecting two metals through a heavily doped region. So this is the reason why we are having two heavily doped N plus regions. So this is the actual MOSFET structure. In this we are having P type. This is actually N MOSFET. So for N MOSFET we should take P type as the base material. So here we are using P substrate. In that P substrate we are having two heavily doped N plus regions, and above that we are having one insulating layer which is very thin, and over there we are having one metal layer, that is what gate, and two N plus regions will be acted as a source and drain region. So here we are having p-type substrate, source, drain, gate. This is what actual MOSFET structure. Thank you.